Today we're going to talk about how to use long division of polynomials to simplify a rational function. To complete this problem, we'll identify components of a rational function, set up the problem, and then complete the long division. In this particular problem, we've been asked to use polynomial long division to simplify the function f of x equals the quantity x squared plus 2x minus 7 divided by the quantity x minus 2. The first thing we need to realize is that we're dealing with a rational function, and remember that a rational function is the quotient of two polynomials, meaning we have a fraction with a polynomial in the numerator and a polynomial in the denominator. When we have a rational function where the degree of the numerator is greater than or equal to the degree of the denominator, meaning that the largest exponent here on the x variable in the numerator is greater than or equal to the largest exponent on the x variable here in the denominator. In this case, the exponent in the denominator would be equal to 1, x to the first power. Here we have 2 greater than 1. Whenever the degree of the numerator here is greater than or equal to the degree of the denominator, it's possible to use polynomial long division to simplify this rational function. And polynomial long division is the same kind of long division that you learned in grade school. You take the numerator of the fraction and you put it on the inside of the long division problem, so x squared plus 2x minus 7, and you divide that by whatever you have in the denominator, in this case x minus 2. Once you have your problem set up like this, your next step is to figure out what you need to multiply by x here in order to get x squared here. So what do we need to multiply by x in order to get x squared? Well, if we multiply x by x, we'll get x squared. So that means we need to put an x here above the x squared. Then we multiply x here by the entire value out in front here, x minus 2. So x times x minus 2 gives us x squared minus 2x. Once we've performed that multiplication, we go ahead and subtract this second line here from what's underneath our long division problem. So we put the negative sign out in front and wrap this part in parentheses, and we take x squared minus the x squared below it, and we get 0 here. We take 2x and we subtract a negative 2x, which is the same as adding 2x because these negative signs here cancel each other. So we end up with 2x plus 2x, which gives us 4x. So we write that result and then we carry down, remember from long division with real numbers, we carry down this value here, so we get minus 7. Now we need to figure out what we need to multiply by x in order to get 4x. Well, if we multiply x by 4, we'll get 4x. So we go ahead and write a plus 4 here on top. Then we take 4 and we multiply it through x minus 2. So 4 times x minus 2 gives us 4x minus 8. Then we do the same thing we did in the last step where we subtract this quantity from the quantity above it. We get 4x minus 4x, which gives us a 0. And then we get negative 7 minus a negative 8. In other words, negative 7 plus 8, which gives us a plus 1. From this point, we'd continue this process, except that we'd have to figure out what to multiply by x in order to get 1. What we realize is that we'd have to multiply x by 1 over x in order to get 1. Once you get to the point where you have to start multiplying this quantity out in front here by a fraction, you know that you're done and you call whatever you have left down here your remainder term. So 1 will be our remainder term, and when you have a remainder, you take whatever's down here at the bottom, in this case just 1, and you put it over what's out in front. So you have x plus 4 plus 1, that remainder, divided by whatever's out in front, the denominator of your original function, in this case x minus 2. And that's it. The result of our polynomial long division is x plus 4 plus 1 divided by the quantity x minus 2.